NASA's Mars InSight lander has sent back the first audio recordings from the Martian surface. InSight sensors captured these haunting first-ever sounds of winds blowing across the red planet's surface just days after successfully touching down on the Elysium Planitia, a broad, flat, freeze-dried lava plain that straddles the Martian equator just south of the Elysium volcanic province. The sounds are actually a low rumble caused by vibrations from the wind, estimated to be blowing from the northwest at between 5 and 7 meters per second. The winds are consistent with the direction of dust devil streaks in the landing area, which were observed from orbit. InSight principal investigator Bruce Bannert from NASA's Jet Propulsion Laboratory in Pasadena, California, says capturing this audio was an unplanned treat. It came about because two very sensitive sensors on the lander detected the wind's vibrations. One was an air pressure sensor inside the lander. The other was the seismometer sitting on the lander's deck, awaiting deployment by InSight's robotic arm. The two instruments recorded the wind noise in different ways. The air pressure sensor, which is part of the auxiliary payload sensor subsystem designed to collect meteorological data, recorded the air vibrations directly. On the other hand, the seismometer recorded vibrations on the lander itself, caused by the wind moving over the spacecraft's 2.2-meter diameter solar panels. These sensors are capable of detecting vibrations at frequencies of nearly 50 Hz at the lower range of human hearing. The solar panels on the lander sides respond to pressure fluctuations from the wind. And when mission scientists looked at the direction of the vibrations coming from the solar panels, it exactly matched the expected wind direction at the landing site. Unlike the vibrations recorded by the seismometer, the audio from the air pressure sensor is at about 10 Hz, below the range of human hearing. This raw audio sample from the seismometer was released unaltered, followed by a second version raised 2 octaves in order to be more perceptible to the human ear, especially when heard through a laptop or mobile speakers. The audio sample was then sped up by a factor of 100, which shifted it up in frequency. This is the only phase of the mission during which the seismometer will be capable of detecting vibrations being generated directly by the lander. That's because in a few weeks' time it will be placed on the Martian surface by InSight's robotic arm. It'll then be covered by a domed shield to protect it from wind and temperature changes. Mind you, it will still be able to detect the lander's movements, but they'll be channeled through the Martian soil. For now, it's recording vibrational data which scientists will later be able to use to cancel out noise from the lander when the instrument's on the surface, allowing them to focus on detecting Mars quakes. When earthquakes occur on Earth, their vibrations, which bounce around inside the planet, make the planet, sort of ring, similar to the sound a bell creates. InSight will confirm whether tremors or Mars quakes have a similar effect on the red planet. It'll detect these vibrations and in the process tell scientists about the red planet's deep interior composition and structure. NASA's Mars Interior Exploration using Seismic Investigations, Geodesy and Heat Transport, or InSight mission, is the first probe designed to directly study the interior of another planet. It'll study the structure of the Mars' deep interior, allowing scientists to better understand the formation and evolution of the red planet. InSight was launched aboard an Atlas V rocket from Space Launch Complex 3 East at the Vandenberg Air Force Base in California on May 5, 2018. It was the first interplanetary mission to be launched from Vandenberg. InSight landed on the Elysium Planitia on November 26, 2018, for what will be a 2-year mission. The lander is deploying 2 instruments directly onto the red planet's surface using its robotic arm. One is the seismometer we've been talking about. It's designed to measure microscopic ground motions, providing detailed information about the interior structure of Mars. The seismometer is so sensitive, it'll also detect atmospheric waves and gravimetric signals, that is, tidal forces from the Martian moon Phobos as it orbits above. The seismometer is supported by a suite of meteorological tools designed to characterize atmospheric disturbances that could affect the experiment. These include a vector magnetometer to measure magnetic disturbances such as those caused by the Martian ionosphere, a suite of air temperature, wind speed and wind direction sensors, and a barometer. The other instrument being deployed by the 2.4-metre robotic arm is a heat flow probe, which will hammer itself up to 5 metres into the Martian soil. As the probe burrows down, it'll release a trailing tether embedded with heat sensors. This should provide unique information about the planet's interior and how it's evolved over time. InSight will also track the lander's radio to measure wobbles in the planet's rotation that relate to the size of its core. A suite of environmental sensors will monitor the weather and variations in the magnetic field.